The inlet angle of runner blades of a Francis turbine is 90 degrees. The blades are so shaped that the tangential component of velocity at blade outlet is 0. The flow velocity remains constant throughout the blade passage and is equal to half of the blade velocity at runner inlet. The blade efficiency of the runner is. Let's look at the solution. Let us construct the velocity triangles of a Francis turbine blade. This is how the inlet velocity triangle and outlet velocity triangle looks like. Here, please note that U1 is the tangential velocity at the inlet. V1 is the absolute velocity of the jet at the inlet of the runner. Alpha 1 is the angle made by absolute velocity at inlet. Beta 1 is the blade angle at the inlet, which is given as 90 degrees. VR1 is the relative velocity at the inlet, and that is equal to the flow velocity at the inlet, and it is given that the flow velocity remains constant and is equal to half of the blade velocity at the runner outlet. And similarly, according to the given inlet conditions, we have the outlet velocity triangle shown in the figure. Let us proceed further. For better understanding, let us reconstruct the same velocity triangles for the Francis turbine again. Now, for any Francis turbine, the blade efficiency of the runner is given as eta B is equal to U1 VW1 by GH, where VW1 indicates the whirl velocity at the inlet and it is U1. So the blade efficiency turns out to be U1 square by GH. Now, according to the energy balance, we have H is equal to HE plus V2 square by 2G. Please note that there will be an unconverted kinetic energy which is reflected with V2 square by 2G. Rewriting the equations, we have H is equal to U1 VW1 by G plus V2 square by 2G. We know that VW1 is equal to U1. The first term on the right hand side becomes U1 square by G plus we have V2 is equal to also U1 by 2. So the right hand side second term becomes U1 square by 8G. Therefore, H becomes 9U1 square by 8G. Hence, the blade efficiency of the Francis turbine is eta B is equal to U1 square by GH. Substituting H is equal to 9U1 square by 8G in the denominator. Upon simplification, we get the blade efficiency as 89%. The correct answer to this question is option D.